Alright guys, so today we're going to finish the last couple pages of the packet that we did yesterday. So what we're looking at is, well, we had our 10.3 notes, we already finished this, and we went through the different properties. Okay, so looking at those properties again, we're going to finish these little problems right here, the your turn. So it says, for each expression, use a property to write an equivalent expression. Tell which property you used. Alright, so for this one, number 3, if you had A times B, basically times C, but the A and the B are in parentheses, another way that you could write that using one of those properties would be A and change the B and the C to parentheses, and you just use the associative property. Okay, alright, this one here, if you distribute the y to the 3 and the y to the 4, you're using the distributive property, and you would get 3y plus 4y, and that's the distributive property. Okay, this last one, if you just change the order of those numbers around and put 7 times 6, that's the commutative property. Okay, commutative. Alright, so remember guys, you should be turning in page 280 today. That was what we worked on in the middle group yesterday. So make sure you get that turned in today. If you have any downtime, you could work on that for a minute and get it turned in. But we're going to move on here. So what we're talking about today are parts of an algebraic expression. Okay? And if you have 3y plus 4y, we're going to call these terms. Okay, this is a term and this is a term. And we're trying to combine like terms. Alright, so okay, just turning my music down for a second there. So some of these words, they kind of cut off on our paper. This is variable. This is term. This is coefficient. Coefficient. There we go. And the last one was like terms. Okay. So a variable is a symbol that represents an unknown quantity. A term, when addition or subtraction signs separate an algebraic expression into parts, each part is a term. Coefficient is the number in front of the variable or variables in a term. And the last one, terms that have the same variables, raised to the same exponent. Raised to the same exponent. Okay? So those are like terms. Terms that have the same variables raised to the same exponent, but could have different coefficients. Okay? So just remember, the 3 is the coefficient, the y is the variable. Alright, so let's flip over to the back of the page here. Really quick, I was going to say, I'm kind of trying to test to see who's listening to the video and who's just fast forwarding it through it. So if you are listening to the video and you have your first name begins with a J, an O, a B, an S, a K, or a C, come see Mr. Heyer for a piece of candy. Okay? Alright, let's flip over to the back page here. You can pause the video and then come get the candy, and then we'll continue on the back page here. Alright, So what we're looking at now is how to combine like terms. So to combine like terms, we add together items that are the same to make a simplified, shorter list of items. All right? So if you took this order, consider the following family takeaway order. So if your family went out to eat and you ordered a bunch of stuff, all right, so we have burgers, fries, and drinks. All right? So when you use math or algebra, you could write it as 2B, the B stands for the burgers, okay? 2 burgers plus 1 fry, F, plus D, a drink, plus 3 burgers, plus 2 fries, plus 2 drinks. Okay, so if we combine like terms to make this shorter, we get a simplified list as follows. Okay, so we have 2 burgers here plus another 3 burgers for a total of 5 burgers. So we're going to put 5B. We have 1 fry plus 2 fries is equal to 3 fries. So we're going to put 3F. And we have 1 drink plus 2 drinks is 3 drinks. So we're going to put 3D. Okay, so we simplified all this right here, okay, into this. This is a lot easier to look at. Okay, that's all we're doing when we combine like terms. When they say combine like terms, that's what they're talking about, putting these like terms together. Okay, so let's practice a little bit. If we have 32y and we added 5y, what are we going to get? Well, why don't you guys pause the video a second, put what you think, and then unpause the video, see if you're right. Okay, so I got 32y plus 5y. That's going to be 37y. Okay, next one, 6b plus 7b minus 10. All right, the like terms are the b and the b. The 6b and the 7b are like terms. This is just a number, so that is not a like term. So I combine the like terms. I have 7b and 6b. That's going to give me 13b. And then I'm just going to rewrite the rest of the problem, minus 10. Okay? Once again, pause the video if you think you can solve this one. And unpause it when you have the answer. Alright, so I have 2x, 3x, and 4. So these are like terms, my x's. I have 2x and 3x, make a total of 5x. And then I'm just going to put plus 4 because I can't combine that with anything. If there are other numbers afterwards, I can combine the numbers. If they're just numbers, I can combine those. But since this is the only number, I'm just going to leave it alone. I'm just going to put plus 4. Alright, so here, what you're looking at is the distributive property, okay? You distribute the 2 to the y and the 2 to the 5x. So you need to rewrite this problem. You're going to have 3x. So distributive, you take the 2 and you go to the y, so that's 2 times y basically. So I'm going to keep my plus sign, plus 2y, and I distribute the 2 to the 5x, which is going to give me, I keep the plus sign, plus 10x. Okay? So now I'm looking for like terms. Well, I have x's, right? And then I have this y, that's different. So I can combine my x's, and I'm going to make 13x, and then I'm just going to rewrite the y, plus 2y. Okay? So hopefully this is starting to make a little sense here. Let me show you another problem right out to the side here. I'm going to show you this. If I had 3x plus 2x squared plus 4x minus 10. Alright? Now, my x's are the same, and then I have a x squared, and then I have a number. Those are all different terms. Okay? The terms, now I want to combine like terms. Well, my x's are like. Okay? When you go to express this combining the like terms, you always want to start out with the coefficient that has the variable with the highest exponent first. So I'm going to write 2x squared first. Okay, I use that, I could cross that out. Now notice how the next thing I'm going to look for are my x's. Okay, so I'm going to combine my 3x and my 4x, and I'm going to get 7x. So I use those. And now I'm going to look at my minus 10. I don't have any other numbers, so I'm just going to write minus 10. And this would be my answer combining those like terms. Okay? So hopefully this is making sense for you guys. I'm planning on adding a few slides here, and then we'll look at this a little. We'll have more practice, but hopefully you're starting to get the idea of how to combine like terms. Okay? So you're looking for anything that shares this, that's similar. So if it has, for instance, these have x's, those are similar. If I had something over here after the 10 like plus 4x squared, then I could combine this 2x squared with the 4x squared, but I don't have anything else. So this is how we're doing this. Okay? All right.